So the second part of your notes, the page starts with the angle of depression reminder, just that you are looking down from a horizontal. So sometimes you'll need to draw in that horizontal. It might not be part of your picture. So for instance, here, if I'm talking about a lifeguard sitting on a platform and they're looking down at a swimmer, this triangle can easily be formed here, but you wouldn't necessarily think about adding in that horizontal line. So just watch how we have to sometimes add these in. So for number 5, if I was drawing this from scratch, it says a lifeguard is sitting on a platform looking down at a swimmer in the water. So I would envision that here's this platform and the lifeguard is sitting at the top and the swimmer is down here. And that's fine that they're not actual pictures, right? This is your lifeguard. This is your swimmer. And so this triangle is kind of automatically made, right? Here's the water, so you can envision the right triangle and this hypotenuse here. Maybe I need to extend that. So it says if the lifeguard's line of sight is 8 feet above the ground, so their line of sight, the lifeguard is sitting up here, they are 8 feet above the ground. But they're going to look down at an angle of depression to the swimmer at 18 degrees. This is not 18 degrees right here. Remember, it has to be from a horizontal. So although it's not part of my picture right now, if the lifeguard were just hanging out, sitting, looking straight out, here would be their line of sight. So the angle of depression is down from the horizontal. So from the horizontal, this is actually the 18 degrees. But I hope that you can see that right now, if I kind of drop this line right here, I have another right triangle right here. And you can make that choice. You can use this triangle here, or if you really wanted to, you could use this triangle. And you might be thinking, well, I don't have enough information for this triangle, but you do. Because the fact is that this is a right angle and so is this. So this side here is parallel to this side, which means that this transversal is cutting these two parallel lines, making this angle and this angle, these are alternate interior angles. So I could use this triangle where the 8 feet is over here and the 18 degrees is here, or this triangle where here's the 18 degrees, and since this is 8 feet, so is this. So it's up to you which triangle you want to use, but what we're looking for is how far away is the swimmer from the lifeguard. So if I'm looking for how far away the swimmer is from the lifeguard, then I'm looking for this distance right here. So here's the lifeguard to the swimmer. This is the distance x. Even if I put the x up in this triangle, doesn't matter if I use orange or green, watch how our two equations would be the same. So from the orange triangle, here's my angle. So this side is opposite and adjacent. So we would say that the tangent of 18 equals opposite, which is 8, over adjacent, which is x. Over here, here's opposite and adjacent from 18, so it would also be tangent equals at 8 over x. So both triangles give us the same scenario. So when we're solving for this, we're going to say tangent of 18 over 1, and we're going to set our cross products equal. So 8 times 1 is 8. That's going to equal x times the tangent of 18. So to solve for x, we're going to divide both sides by the tangent of 18. So x equals 8 divided by the tangent of 18. So x is going to be approximately 24.6 feet. So that's that horizontal distance from here to here, the base of where the lifeguard is over to the swimmer. Number 6, a pilot in a helicopter spots a landing pad below. So let's say here's our helicopter, here's our landing pad. The angle of elevation is 73 degrees and the horizontal distance to the pad is 1,200 feet. So if here's kind of the height from the helicopter to the ground, here is that horizontal distance from the helicopter to the helipad. So that means that this distance right here is 1,200 feet. Now in this case, we say the angle of elevation is 73 degrees. So that means up from the helipad, then we would have this angle right here up from that horizontal. This is actually the angle of elevation. So we're going back to angle of elevation here, 73 degrees. They want to know what is the altitude of the helicopter. So this over here, this is your altitude, how high in the air it would be. So we're solving for this side. So in this case, opposite and adjacent. So we would say that the tangent of 73 equals x over 1200. So dividing by 1, we have our cross product. So 1 times x is x, and 1200 times the tangent of 73. So we would have to type this in our calculator, and we get that x, that altitude, is about 3,925 feet. Building A is 480 feet tall, and building B is 654 feet tall. So let's draw our buildings. Let's say that if this is building A, I know that this height is 480 feet. And then if this is building B, this height here is 654 feet. If the angle of depression from the top of building B to the top of building A is 42 degrees. So for an angle of depression, again, from the top of this building, that means I need a horizontal line from the top of this building. So the angle of depression, so the angle formed below that horizontal line from the top of the building to the top of building A. So this angle right here is 42 degrees. So I can draw in my right triangle here. Here's my right angle. And it looks like we're looking for how far apart of the building. So I'm looking for this side here. But what is this height? Well, the top of the building here is 654 feet. So the top of this building is 480. So this distance I'm going to get from taking 654 and subtracting 480 feet. So the top of this building to the top of this building, this is going to be 174 feet. So I have my right triangle. So I have the opposite side and the adjacent. So here we're saying the tangent of 42 equals the opposite, which is 174, over the adjacent, which is x. So solving our cross products being set equal to each other, we have 174 equals x times the tangent of 42. So to isolate x, we're going to divide both sides by the tangent of 42. So x equals 174 divided by the tangent of 42. And when we type that in our calculator, we get that x is approximately 193.2 feet. We have one more problem. Zach is standing at the top of a lookout tower and spots a water fountain below. So let's say here is your tower. Here's Zach. He sees a water fountain. So this is a water fountain down here. If the lookout tower is 75 feet tall, so this side is 75 feet tall, and the angle of depression is 28 degrees. So again, from Zach, if he were just looking straight out, here's the horizontal that we're referencing. So the angle of depression is down from that. So when I connect my line of sight from Zach to the water fountain that he sees, this is the angle of depression, 28 degrees. So I'm creating a right triangle here as well that I can use. And if this is 75 feet, then so is this. It says, what is the horizontal distance between Zach and the water fountain? So this is that horizontal distance that they're looking for. That's X right here. Now, if you had really wanted to use this triangle down here, you could have, because again, these two sides would be parallel. So 28 degrees here, the alternate interior angle here would be 28 degrees here as well. So you could also use this triangle. Either way, it's going to work. But from 28 degrees, I have opposite and adjacent. So again, it's going to be the tangent of 28 equals the opposite side, which is 75, over the adjacent side, which is x. So setting the cross products equal, we would have 75 equals x times the tangent of 28. So isolating x, you would be taking 75 divided by the tangent of 28, and we get that that horizontal distance is approximately 141.1 feet.